In today's lesson, we're going to take a look at stoichiometry. Stoichiometry is the math behind chemical reactions. And the heart of all of this is what we call the mole ratio. Okay? The mole ratio is simply looking at the chemical equation and seeing how any of the two species compare. Species are just the different reactants and products in a chemical reaction. So in this reaction on the screen, N2 is a species, H2 is a species, and NH3 is a species. Once again, the coefficients here, remember there's an implied 1 for N2, and of course 3 for H2, and 2 for N3. So we have many different mole ratios, right? We can say that 1 mole, if I could write it out here, 1 mole of N2, right, will react with 3 moles of H2. Okay? This is simply the ratio of nitrogen to hydrogen in this chemical reaction. So they're going to be different for every chemical reaction. And another ratio we could write is 2 mole of NH3. Okay, is produced from 3 moles of H2. Okay. So we could just write anything, any one of these species over the other, and remember these numbers simply come from the coefficient. In this case, for the NH3 or ammonia, that's 2. For hydrogen, we write a 3 here because there's a 3 in the chemical equation. Okay, so that again is just telling us the same thing as the entire chemical reaction, but we're just identifying or comparing 2 of the species in the chemical reaction. So let's look at how that's going to help us. Okay, so when we're solving problems with mole ratio, it's always moles of what we're looking for. Okay, we call that B, divided by the moles of what we were given, A. So we're able to see the relationship between these two and calculate out how much we may need to produce or how much is going to react depending upon what we care about. So let's look at a practice problem for mole ratios. Sorry about that. Alright, if we see at the top of the screen, okay, we have moles of A converting to moles of B. And once again, it's simply that mole ratio that we saw and talked about on the previous screen. So we have the same equation, and we started off with 22.3 moles of H2. Okay. So that's just what we were given. We want to see how many moles of NH3 we can produce. Okay, so we've got our factor, and we're going to multiply by a mole ratio. Once again, what we're looking for, oops, this should have mole in there because it's 22.3 moles of H2. Okay, what we're given, as we said, goes on the bottom. Okay, it's mole of H2. Okay, we need that so it cancels out. We're converting from this to something. And in this problem, the moles of ammonia, or NH3. Okay. But we still have to get the numbers, and once again the numbers come from the chemical equation. Right? So for NH3 there's a 2 in front of it. Okay. So for this equation, anytime we have NH3 we'll have 2, because 2 moles of NH3 are related to the other things. And for H2 we see a 3 in front of it. Okay. So we have a 3. We simply multiply those out, and as you'll see, the answer down below here is 14.9 moles of NH3. It's 22.3 times 2 divided by 3. Okay. And that is mole ratios.